Hello and welcome to Tech Simplified TV. And this is the third episode in LVS series. In our first episode, we have discussed about basics of LVS and tried to understand basic information about POS tool NETGEN. In our second episode, we learned how to install NETGEN. In our today's episode, we will take 3 examples from NETGEN repository and run them at our end. We will see what happens when global definition is missing. We will try to understand what happens when there are mismatch in instances between 2 spice files. So if you are interested, stay tuned and stay focused till the end of the video. So now let's take a look at the pointers we are going to discuss in today's episode. First, buffer circuit description. Second, comparison of spice files. Third, explanation of first example. Then running second example and explanation of second example. After that, running third example and explanation of third example. Now here we will start with buffer circuit description because buffer circuit is used in the example. We'll try to understand what is a buffer circuit, and then comparison of spice files. We are using the given spice files. There are many differences, and we will try to understand by comparing these 2 files why we need an LVS tool. And explanation of first example. In our last episode, we have used one given example or tutorial from the website, and now we will understand the example we will understand. So that is the explanation, and more 2 example, more 2 tutorial we will run here and their explanation too. So now let's move to the first slide. Now buffer circuit. This is a buffer circuit. Buffer circuit is 2 inverter comprised with 2 inverters. So here is it's 0, it will be 1, and since it's 1, it will be 0. So voltage level there will be no change. And a single inverter is comprised of 2 MOSFET. One is PFET, another one is NFET. So PFET and NFET, their width and length are mentioned 1.8 micron, 0.6 micron respectively, width and length. And here for NFET is also same. So this is the buffer circuit. That data we will use in the spice files. Now comparison of those 2 spice files. So in our last episode we have seen we were taking 2 spice file, one buffer A.spice, another buffer B.spice. We know in LVS it's basically layout versus schematic. So from schematic we get one spice file and another file we get from layout. So extracted from layout basically. So that 2 spice files we compare, and here let's see what differences we can spot. First of all, the left one is generated from layout in a magic, that is layout extracted spice, and this one is from schematic. So here this is the transistor numbering, starts from 1000. It's a convention for the tool. This is pin order, in which order pins are mentioned. Now PFET, width and length, AD and PD are drain diffusion area and perimeter, and here it's ASPS, area and perimeter of source diffusion area. So these are the parameters mentioned when we are considering this spice file. This one here, out in POS VD. Here convention is neg in out POS. Here convention is in out POS neg. Already in the orientation or order, it's a little bit different. Although both represent same circuit, when we comparing with plain eyes, it seems these 2 are different. Another one is here ADPD, ASPS, these parameters are mentioned, whereas here it's not mentioned. So generated from layout in Magic and created with Schematic capture tool or written manually. These are first difference. Now starts numbering transistor from 1000. Another point is includes detailed about transistor area and perimeter for more accurate simulation. And it uses non-standard keyword back and pin order for inverter subcircuit differs from obviously buffer spice. Here it's MXU1, MXU2, MXU3, and it's list device width, length, area, perimeter, and here list device width and length but lack area and perimeter detail. So more parameters are mentioned in this spice file and less parameters are mentioned, although connectivity wise these 2 present same circuit. In our plain eye, if we try to compare, we will find error. This is the scenario in a very small and simple circuit. And now just think, if the circuit is really big and complex, it's impossible to compare them with eyes. That's why we need tool, and LVS tool is important for that. So we are done with this slide. Now we will move to the explanation of first example. Now here I have created a directory structure with name LVS episode 3 and this is the tutorial 1. Here I will run the tutorial 1 again. So again giving setup file doesn't exist. So here we do not need. Let's make a setup file. It's showing circuit match uniquely. So here it's showing circuit match uniquely. Quit and let's see. This is our output. So it's starting from here, sub-circuit summary, circuit 1 inverter and circuit 2 inverter. In the both spice file, inverters, sub-circuit are inverter. So here PFET 1, NFET 1, PFET 1, NFET 1, number of devices 2. Here also number of devices 2, number of net 6, number of net 6. So net test match uniquely with property errors NFET 1001 versus NFET makes you 2 and that's because of that area and perimeters are absent because of that. And now here again it's sub-circuit pins. Now it's comparing pins. So circuit 1 inverter, circuit 2 inverter, positive, positive, VDD, VDD, negative, negative, ground and 0. So in one file it's defined as ground, in another file it's defined as mismatch. So ground and 0, it's showing mismatch. Out, out, in. Cell pin list for inverter and inverter altered to match device classes inverter are equivalent. Now sub-circuit summary. That is inverter 2, inverter buffer A, circuit 1 buffer A spice, circuit 2 buffer B spice, number of devices 2, number of net 6, netlist match uniquely, cells have no pins, pin matching not needed, device classes buffer A, buffer B spice are equivalent, final result circuit match uniquely, property error that is mentioned. That is in two cases there are some properties mismatch, although the circuit and their functionality is same. So it's match uniquely. In one, their ADPD is ASPS present. In another one, these 4 are not present. This is the output file for run 1. Since we are done with our first example, we will move to second example. This is tutorial 2. We will change in buffer B file while keeping buffer A file intact. Now, open buffer B file. BX. So that file is here. We have not mentioned. Buffer bb.spice and if buffer bx.spice. And here it's VDD0 and after back arrow here VDD0 is not present. We have just erased it in buffer bx file. So let's run it with the original setup file. Here the terminal. Now net ls minus lst NETGEN nvs here buffer. We are keeping the buffer A file unchanged. Of here bx he got spice buffer A file, buffer B file and original setup file, that is blank one setup file, and here it's run 4. Netlist do not match, so Here pin VDD connections are tied together, and in MX1 pin VDD connections are no connects. Here pin ground connections are tied together. Here pin 0 connections and no connects. Here VDD, no pin, node is VDD. Neg is present, no pin, node is 0. Pin is not present. So it's basic that part is not connected. So netlist do not match. Port matching may fail to disambiguate symmetries. Cell have no pins. Pin matching not needed. Device classes and device classes are equivalent, although netlist do not match, because pin connection doesn't match. Port matching may fail to disambiguate some symmetries. Here also we will now run with the modified setup file and it will run. So that modified setup file has that to be, look, global buffer vx spice 0 global buffer vx dot spice vdd. But in buffer vx file 0 is global and vdd is global as we declare now. So now NETGEN, this is the fifth run, setup tut to be, and here the result has come, circuits match uniquely. Let's see the output file. Netlist matching uniquely now, because we have mentioned the global connection in setup file. So now we will move to third example and its explanation. This is the third one. Now let's open the terminal here. tk-diff like these are two spice files and here both global are mentioned. That is not the issue here. Look here, there are in sub-circuit there are two MOSFETs, M1000, M1001, and here it's MXU1, MX2 and MX3. There are three MOSFETs and here two MOSFETs. So mismatch of number of transistor, that is mismatch. Now let's see what comes in output. And here also we will create a, just using that touch, we will create a setup file. Now LPS run, this is sixth run. Okay, sort 3 dot out. Netlist do not match. Now let's see what kind of error message it has given in the output file. Number from very beginning, that number of devices 2 and number of devices 3. So net mismatches class fragments follow, and here this netlist do not match because of number of devices 4, number of devices 5, number of nets 5, number of nets 5. Pfet source, pfet bulk, here VDD is pfet source 3, pfet bulk 3, pfet drain 1, pfet gate 1. So here it's mentioned that here number of devices completely mismatched. 3 devices here and here 2 devices. Number of device is mismatching here. So one more from schematic we are getting one more transistor, whereas from layout extracted spice file we are getting less number of devices. So that's all for today's discussion, and we have completed 3 examples till now and their explanations. So thank you for watching up to this point. Don't forget to like, share and subscribe. If you have a dislike, please put it as a comment. If you have a question or query, also put it as a comment. Thank you again and bye for today.